Welcome to NOAA Live Alaska. My name is Lisa Hiruki-Raring, and I'm going to be moderating today's webinar. This series is a collaborative effort by NOAA Fisheries Alaska Fisheries Science Center, where I work, NOAA's Alaska Region Collaboration Network, and NOAA's National Weather Service. This webinar series is designed to help you get to know NOAA's work in Alaska and how we connect and work with your communities. NOAA, the National Oceanic and Atmospheric Administration, studies the ocean and the atmosphere and where the two meet, from weather to ocean to the animals that live all around us. All of our speakers work for some part of NOAA or work in partnership with NOAA. We hope this gives you a sneak peek at different career paths that you might be interested in. I wanted to highlight that if you would like a NOAA Live sew-on patch, there's a link to the NOAA Live website where you can fill out a form to have one sent to you. And if you're a classroom teacher, let us know how many patches you need for your student. We wanted to give something back to our regular viewers and our first-time viewers as well. And my colleague out in Woods Hole, Grace Simpkins, has been sending out NOAA Live sew-on patches to our viewers. So if you're interested, please check out our website. Today, we're introducing you to Kaitlyn O'Brien, who works for NOAA's National Weather Service's Anchorage Forecast Center in Anchorage, Alaska. While we'll be talking about NOAA's role in research and stewardship, we want to recognize that we're all coming to you from the traditional lands of Native communities who have substantial Indigenous knowledge and much to share with us. In Alaska, the National Weather Service's work is conducted all over the state, which includes the traditional homelands and waters of the Inupiat, Yup'ik, Siberian Yup'ik, Athabaskan, Anunga, Alutiiq, Sugpiaq, Eyak, Tlingit, Haida, and Tsimshian. We're honored to acknowledge that Kaitlyn is presenting this webinar from Anchorage, Alaska, the ancestral land of the Dena'ina people who have stewarded this area for thousands of years. The community thrives thanks to their continued sharing of wisdom, vision, values, and leadership. We would also like to acknowledge that we're hosting this webinar from the traditional lands of the first people of Seattle, the Duwamish people past and present. We'd also like to thank our American Sign Language translators, Crystal and Lily, who will be translating for us today. A few guidelines before I hand you over to our speaker. You're all muted because we have a lot of people on the line and we want to make sure everyone can hear our speaker. However, there's a box where you can write questions. We encourage you to ask them as we go, and my colleague Chris Beyer and I will be keeping track of questions for Kaitlyn behind the scenes. She'll stop every now and again and answer a few questions. We may not get to all of our questions, but we'll try to answer as many as we can. All right, I'll hand it over to Kaitlyn to introduce herself.
Hi, and good morning, good afternoon, whatever time of day it is for you. I'm really excited to be here and share with you a little bit more about my job and what I do here for the National Weather Service in Alaska.
Okay, Kaitlyn, I think you have to turn on your camera still.
Oh, okay. Sorry about that. Should be here now. Thank you so much. And thank you, Lisa, for having me today. I'm excited to be here and share with you all a little bit more about my job here at the National Weather Service in Alaska. But first, before we dive into that, I wanted to share with you a little bit more about me and how I got interested in weather. So my hometown is actually back on the East Coast. I was born and raised in Blairstown, New Jersey, the northwestern part of the state. And I lived there my whole life until leaving for college. And I had always had an interest in weather since I was young. In fact, there's a picture of me there on the left-hand side in first grade. That's when I can remember being interested in summer thunderstorms rolling through, and even in the winter months, anytime that we had a nor'easter with a lot of snow, I was always eager and really excited to go out and measure the snow falling. So when it came time to decide about what to do and kind of which path I wanted to take, I wasn't so sure. I had always had this interest in weather, but I didn't know if that's what I wanted to do as a career. So for actually the first year of my college studies, I was a nursing major. I had become interested in healthcare and health science, and I really thought that that was the path that I was going to take to go into nursing. But actually, after 1 year of nursing school, I decided that that wasn't for me, and I reverted back to my first love, my first passion, which was weather. And so ended up transferring to a different school and pursuing a degree in meteorology out in Oklahoma. And my time in Oklahoma was actually the first time I had left home, so it was a little bit scary. I didn't know anybody. I didn't have any family out there or friends that I knew, but it was a great experience. It took me out of my comfort zone a little bit to pursue something that I knew that I loved. So a couple experiences that I've had in the workforce. After graduating college, I had the opportunity to work as a excuse me, work as a summer intern on the summit of Mount Washington in New Hampshire. There's a weather observatory up there located at 6,288 feet in elevation, and that was really where I solidified my passion for extreme weather events. I also had an opportunity to work in the private sector, where I worked for a short time for a private weather company in Norman, Oklahoma. And now I'm located in Anchorage, Alaska. So I've kind of bounced around a little bit across the country and have done several cross-country moves, but have enjoyed every experience along the way. A couple of things to share with you about my time at Mount Washington. The severe weather events that we had up there were incredible. In particular, the rime ice growth and the wintry conditions. The picture on the right-hand side is an image of super cooled water droplets that freeze on contact, and they form these long strands of rime ice, these sort of feathery rime ice formations. And in some of the most extreme cases on Mount Washington, there can be rime ice accrual rates of over 6 inches per hour. So that was a really unique thing that I encountered while working on the summit. Also, part of my work at Mount Washington involved taking hourly weather observations, and that included collecting observations like temperature, snowfall, rainfall, observing the wind speed and wind direction. In fact, Mount Washington is well known for a really high wind gust that occurred back in April of 1934. They measured a peak wind of 231 miles per hour. So there's a lot of unique weather that occurs up there on the summit of Mount Washington, and that's what really got me interested, I think, at first, for experiencing extreme weather events. And then in 2016, I had the opportunity and the chance to move to Alaska, and I could not turn that down. I've been here since then, forecasting now at the Weather Forecast Office here in Anchorage. And I've also had a lot of unique experiences so far in my time here. I've traveled to different communities across the state, and I've been able to partake in unique events and outreach programs. So it's been really, really great working here now in Anchorage. And I'm still interested in extreme weather events, and there's a lot of those that can occur in the southern portions of Alaska too, as we'll learn about shortly. So a little bit more about where the National Weather Service is located across the state. We have several forecast offices that focus specifically on forecasting the weather. And our offices are located in Fairbanks, Anchorage, and Juneau. Up in Palmer, Alaska, we also have the National Tsunami Warning Center, one of 2 national centers. So we have an office located there. And we also have several other offices located in Anchorage, including the Alaska Pacific River Forecast Center and the Alaska Aviation Weather Unit and Volcanic Ash Advisory Center. So there are a lot of unique opportunities within the Alaska region of the National Weather Service simply because Alaska has a lot of unique challenges to the weather. Some of our service programs are focused on aviation. We have a large population of general aviation across the state, so we provide specifically tailored forecasts for pilots. We also focus on climate and climate research. We have several different climate sites across the state where we're collecting weather information and monitoring climate. Fire weather is a concern for Alaska, so we're constantly forecasting for any fire weather concerns and cooperating with a lot of different agencies across the state during fire weather season. We also have a focus on marine weather and sea ice. In fact, one of the only programs in the Weather Service is located right here for sea ice forecasting. And so that's a really unique opportunity that we have. We can service lots of different people who are interested in marine weather and sea ice forecasts. Of course, we also provide general forecasts across the whole state and watches, warnings, and advisories anytime that we see the possibility or the threat of adverse weather conditions. Our River Forecast Center focuses specifically on river breakup and also in the fall, freeze up. So you may actually recall one of the previous webinars a couple of weeks ago, my colleague Crane Johnson was giving a presentation about breakup season here in Alaska. So that's one area as well that we focus on. And as I mentioned, up in Palmer, we have the National Tsunami Warning Center. And you may also recall a former webinar presentation from my colleague Summer, who talked about their operations there. So really unique opportunities across the state of Alaska with unique concerns that we're worried about, things like earthquakes and tsunamis, flooding, anything like that is something that we would focus on in our programs. And lastly, volcanic ash. Our Aviation Weather Center specifically focuses on volcanic ash. And in fact, the image on the right-hand side was an eruption that we had just last week, a week ago from today on Tuesday. The Great Sitkin volcano erupted, and that was an image where a lot of the ash plume was being dispersed into the lower levels of the atmosphere. And of course, that's a major concern for pilots and for aviation. So the Alaska Aviation Weather Unit focuses on that. So we have a really large area of responsibility. And as I mentioned previously, our area is split up across 3 different offices. We have the Weather Forecast Office in Fairbanks that is responsible for a large portion of the northern half of Alaska. The Weather Forecast Office in Anchorage here is responsible for a very large area across all of the Aleutian chain, the area of the Bering Sea. And then we also have the Forecast Office in Juneau, responsible for the panhandle of Alaska, as well as the eastern part of the Gulf of Alaska. So really large area of responsibility for all 3 of our offices here. Some of the information that we provide specifically from the weather forecast offices includes your typical forecasts. So if you're one of the people that accesses the forecast online, that's one way to get your forecast information. We specify weather conditions in regards to flooding, aviation, fire, marine, climate, and all of those other programs that I mentioned. We also provide support to other agencies for both planned and unplanned events. In addition to that, we offer outreach and educational programming. We provide data to the public. So anytime that you want to access satellite data or climate data, that's all available on our website. And lastly, we have volunteer weather programs. That includes our Weather Spotter program, where you can sign up to report observations so that we can actually have confirmation of what has occurred across the state. And we also have the Cooperative Observation Program. This is a group of volunteers that dutifully submit observations at the same time every day, and that really helps us to build our climate record across the state. And so at this time, I've thrown a lot of information out at you, but if you do have any questions, I'd be happy to answer them if you'd like to type them into the chat.
Thanks, Kaitlyn. We do have a couple of questions. There was a lot of interest in what you had talked about with the volcanic ash and how that can affect things. So Theodore was wondering, was there lava in the volcanic eruption? And there is also a question about how does the volcanic ash affect planes?
Yes, great question, Theodore. So sometimes there is lava visible. The best way for us to see that is through the use of satellite imagery. And some of the technology on the satellite can determine heat And so anytime that we see a heat signature, we know that there could be lava there. In that particular eruption last week, I don't believe there was any visible lava. And as far as ash affecting planes, when planes are flying through the air, if there is ash from an eruption, it can severely damage the engine. So you never want to have ash particles in the engine of the aircraft. So that's the biggest concern. Great questions.
Great. And then another question was, are there a lot of volcanoes in Alaska that you have to keep track of? And Michelle was also wondering, how often do volcanoes erupt?
Great questions. Yes, there are a lot of volcanoes in Alaska, particularly along the Aleutian chain. I'm going to say over 50 that need to be kept track of. Luckily, we have some partners at the Alaska Volcano Observatory that help us with that. And Lisa, if you could repeat that second question.
Oh, so one of the questions was, Michelle was wondering, how often do the volcanoes erupt?
Oh, great question. So in terms of how often we see volcanic eruptions, it's kind of hit or miss. I would say generally on average, every couple of weeks. It just depends on the activity. That's one of those things that we can't really plan for. We just know when it does happen.
Great. And then there was also a question about fire forecasting. One of our viewers was wondering whether forest fires have become worse in Alaska the way that they have down in the lower 48.
Excellent question. I don't know the answer to that for sure. However, I can recall one particularly bad fire weather year that we had was recently in 2019. I don't necessarily know across over time if it's getting worse. My suspicion is that yes, it probably is. Just from what I've observed in my time here, 2019 was a pretty active fire weather season for us here in Alaska. But I presume that that trend is likely to have an increase in fire weather activity similar to that of the lower 48.
Thank you. The other question that we have was about rime ice. You had mentioned when you were up on Mount Washington that there was a lot of rime ice. And for those of you in our audience, I did put the spelling in the chat box. It's R-I-M-E, if you want to look that up later on the internet to get more information about it. But one of the questions was, are there specific conditions that promote the formation of rime ice, and does that happen in Alaska as well?
Excellent question. It does happen in Alaska. I believe that the conditions necessary for rime ice is to have super cooled water droplets. And what that means is you have water in a liquid state, but the temperature is below freezing. However, the droplets are so small and so fine, they don't freeze until they come in contact with something. And so this is naturally a concern for planes flying as well. Part of the work that the Alaska Aviation Weather Unit does is they forecast for icing conditions in the higher levels of the atmosphere, specific for aircraft to know where those higher riming rates are.
That's very interesting. I think for a lot of us, it was the first time we'd heard that term rime ice. So it's interesting to hear that and what conditions can promote that, and that you have to be careful of that. We have another question about volcanoes. Allie was wondering how deep are volcanoes, and I'm not sure whether that means whether Allie was thinking about volcanoes that are underwater or whether that means that I'm not really sure whether that refers to underwater volcanoes, which we're not talking about here, right? We're talking about volcanoes that are above land that you were keeping track of. Is that right?
Correct. Yes. Our big concern with volcanoes is the ash that they produce. And so as a weather forecaster, something that I'm looking at is what are the winds doing around at the time of the eruption, and where is that ash traveling? So yes, all of the volcanoes that we typically monitor are the ash plumes, and so above ground.
And so, oh, she just wrote in something else to clarify it. And so she was wondering how high above the ground are the volcanoes and where, and I guess I would add to that, are there particular elevations that you need to keep an eye on?
Yes, great question. So typically, I believe a lot of our volcanoes are anywhere from 6,000 feet in elevation to 10,000, maybe even 12,000 feet in elevation. And so anytime that they do erupt, the concern is how high will that ash travel? So from the top of the volcano and higher, you know, where is that ash traveling and how high is it being dispersed? So luckily we have some really smart folks at the aviation weather unit to track that because those folks are more focused on the airspace. In the weather forecast office, we sort of focus on the surface and the ground. So there are times where you have a pretty explosive eruption and you might actually see ash fall. So what that means is ash is reaching the surface, and that's something that people would want to know about. So that's where the weather forecast office comes in. And as far as ash being dispersed in the airspace or just in the atmosphere, that's where the Alaska Aviation Weather Unit focuses on.
Wow, that's really interesting. I didn't realize that there were those different ways of looking at the ash. So I think that we'll hold on to the rest of our questions for right now, and because I know that you have a lot of other interesting information to cover, and then we'll just move on with our next section and try to line up our questions from there.
Excellent. That sounds great, Lisa. Thank you. And thank you all for those excellent questions. All right. So now that you have a little bit of an understanding of what we do and where our weather offices are located here in Alaska, I want to talk to you a little bit more about how we can put a forecast together. So step one is gathering all of the data. And my question to you all in the audience, I'd like to ask you, what kind of weather information do you think is important to collect? Feel free to enter that into the chat.
So for all of you guys in our audience, please enter into the chat box or into the question box what kind of weather information you think that it's important for our forecasters in the Weather Service to collect in order to be able to provide our forecasts. So I'm going to wait a few minutes to see what people are saying. I can see people are already putting their answers into the box. Michelle is saying temperature. Theodore is saying storms, wind, and ice. Texas is saying pressure, wind speed, and temperature. Ali is saying volcanoes. I see that there's some other folks that are saying the wind speed. Paul and Alice are saying temperature at different altitudes. So it means that so that there's a difference in height as well. And I know that some folks are thinking about some of our webinars that we've seen before. Ali is saying snow because we had one about snow measurements. Anne is saying humidity. Paul and Alice are saying snow depth and rainfall amount. So we have a lot of ideas about the different kinds of data that you want to gather. So what do you think, Kaitlyn? What can you tell us?
Excellent. Yes, all of those answers are correct. There is a lot of data to track and to collect and to confirm at the surface, and as somebody mentioned, higher up in the atmosphere. That's definitely information that we want to know. Where is our freezing level? Is it at the surface or is it higher up in the atmosphere? So yes, lots of data to collect before we even think about getting into what the forecast is going to be. So one of the ways that we collect these data are through automated weather stations. And here's an image that has a lot of different instrumentation. And we have sites just like this observation site located across the state. There's definitely one of these sites at every airport. So we have the conditions, we know what the conditions are at the surface across a variety of places across Alaska. And so just to give you an idea of what that map looks like, if you were to zoom in, you would start to see a little bit more data points fill in. But what I'm looking at here and what kind of draws my attention to this map is the directions that the winds are coming from. That's what's illustrated by those wind barbs. And also the temperature at the surface temperatures are things that I'm going to be looking at and tracking. If I zoom in on this map over the Anchorage area, you can see I have a lot of different data points, and this really helps me as a forecaster to understand what is going on in the present moment, what is happening at the ground on the surface. And so another thing that we want to know and understand and collect is to help us observe the weather is the use of satellites. We rely really heavily on satellite imagery. In fact, up here in Alaska, one of the useful orbits that we use is the polar orbiting satellite. And so that's something that we can, that's a satellite image that we can use to get images of what's happening on the surface. But we're looking from a camera that's higher up, in fact, in space. And so we're able to use that imagery to confirm and look down at Earth's surface and see what's going on. So here's an example of a really beautifully wound up area of low pressure over the Gulf of Alaska. And you can see very clearly the clouds or where the low pressure center is, where that circulation is. And so having this image can really confirm for us what's going on from a different vantage point than just being an observer on the ground. Here's another satellite image. This is actually an image taken during what we call a northerly outflow wind event. So along the northern Gulf Coast, we had really strong northerly winds, maybe around 30 to 50 miles per hour gusting out of the north. And what happens is in places particularly like the Copper River Basin and the Copper River Delta, we see a lot of glacial silt. And so on this particular day, we were lucky enough to have clear conditions, those gusty northerly winds, and we can actually see the dust and the glacial silt streaming out over the Gulf of Alaska there. So that's what that satellite image is depicting, and that's what we're seeing over the water. Sometimes we need to distort the images from the satellite a little bit. And so this is what we call false color imagery. And this can help us key in on some specific features when we change the color of the image a little bit. So the pinkish kind of tint gives us an understanding of where the clouds are located, and that can help us distinguish between clouds and, say, sea ice, which you can see has a little bit more of a blue hue along the coast of Alaska there. Again, too, we are able to observe in this image that we have more northerly winds coming out of the northern Gulf Coast there, and there are little signatures of that glacial silt and glacial dust coming out of the valleys there. Another type of image, satellite image that we can look at is what we call day cloud phase distinction. And basically what this means is the colors are changed a little bit so that the forecaster can determine where the water vapor is, the lower level clouds, versus the higher level clouds, which look like ice crystals and are much higher up. So in this particular image, the colors, the orange and the yellow kind of green color, indicates that those are much higher level clouds. Those are in fact ice crystals, so typically like a cirrus cloud, thousands and thousands of feet above the surface. Whereas the bluer tint, that indicates that that's a lower level cloud, and that can really help the forecaster track where low level stratus or even fog can form and develop. So having the satellite imagery is extremely useful for us to know and track what the weather conditions are. You might be wondering in this image what the green represents. Those are actually snow-covered mountains. And so you can pretty clearly see the Alaska range up north of the Anchorage area, where you can see that it's all snow-covered. So that lime green helps us distinguish ice and snow from the clouds. In addition to satellite imagery, we rely heavily on radar. And radar is an instrument that we use that utilizes radio waves. It basically sends out a pulse of energy, and that energy bumps into precipitation. And whether that is a rain droplet or a snowflake, or maybe it's a hailstone, we can then determine the type of precipitation that's out there based on the signal that's coming back into the radar. So it really helps meteorologists and forecasters know what type of precipitation is out there and what type of precipitation is moving in or tracking across an area. Here's an example of what our radar data looks like. So here's a map of southern Alaska, and you can observe just by looking at this image from the radar, we have a lot of precipitation spreading along the northern Gulf Coast and also over Anchorage, as well as along the Alaska Peninsula down there near the Bristol Bay area and Shelikof Strait. And so this was actually taken just yesterday. So if you were in the Anchorage area, or if you were in any one of these locations where the precipitation was falling, it was a cloudy, rainy day here. We also use weather balloons to collect data. As was mentioned earlier, somebody said, you know, it's really important to know what's happening higher up in the atmosphere, not just what occurs at the surface. And that is so true. And our tool that we use to determine the data that's occurring higher up in the atmosphere is the weather balloon. And so every day, twice a day, we launch a weather balloon from our office location, and we are collecting, we're using instruments attached to that balloon to collect information, including temperature, humidity, wind speed, and wind direction. And so now I'm going to call up a different window and share with you a quick video. One thing I want to note about this is we used to launch the weather balloons manually, but over the last several years, we've actually transitioned to what we call an AutoLauncher. And it's a machine that will actually inflate the balloon, attach the instrumentation, and then launch without anybody needing to go do the physical work of launching the balloon. So we now are using those, and this video will share with you a little bit more about how that works. So let me just share my screen. Okay, and one moment here as I play this video.
A new chapter in weather observation has started in Fairbanks, leading to improved support for community partners and better forecast and warning services for interior Alaska. Twice daily in 13 cities and villages around the last frontier, along with nearly 900 sites around the world, a weather balloon is filled, tied to the flying weather station, and released to collect weather information shared with scientists around the globe. But for the first time in nearly 80 years, a machine automatically filled the Fairbanks weather balloon, turned on the weather sensor, and launched the balloon with only a push of a button by the team at the Fairbanks Weather Forecast Office.
3, 2, 1, launch.
The machine is called an AutoLauncher, and its installation is part of the Evolve National Weather Service Alaska demonstration project. Each day, this AutoLauncher will unlock up to 8 precious work hours of your Fairbanks National Weather Service team. Instead of preparing and launching weather balloons, we will spend more time on forecasting and supporting your community decision makers whose jobs are keeping people safe. This pioneering effort began in Kodiak and will expand to the remaining launch sites across Alaska into 2019, adding dozens of daily hours for forecasters to focus on your Alaska weather, keeping you ahead of the next storm. This is how we build a weather-ready nation.
Okay, and Kaitlyn, don't forget to unmute yourself because the video mutes you.
Thank you, Lisa. So that gives you a good idea of how our weather balloons work and where we're launching from. And all of these data are used, which we'll talk a little bit about in the next section, to better forecast and predict the weather. So at this time, I'll go back to my presentation here. And I believe I can help to answer any questions that you might have about some of the material that I shared.
Okay, great. And Theodore was wondering, what was the little red red thing that was underneath the balloon? He was wondering whether it was a parachute.
Yes, yes, Theodore, you're correct about that. That was a parachute. So what happens is the balloon is launched and it reaches the very, very top level of the troposphere, which is about 100,000 feet up. And then the balloon bursts and the parachute slows the descent of the instrument back down to Earth's surface.
And Allie was wondering, how do the weather balloons not fly away, like go, you know, places that you don't want them to go? Oh, Gabe,
Yes.
sorry. Gabe was asking that.
Great question. Well, we cannot control where the weather balloon goes. The wind and the direction of the wind is going to take that balloon wherever it may go. We have no control over where that is traveling. But that's also part of the data that we want. So by letting it be released into the atmosphere, we're tracking what the winds are doing at each various level of the atmosphere as it's rising higher and higher. So we don't have control over where it travels.
So a related question to that is, do the winds go at different speeds, at different heights in the atmosphere?
Yes, excellent question. They do. In fact, typically around what we call the 500 millibar level, that's where we see our strongest winds, and that's in association with the jet stream. So as the balloon is rising higher and higher, the pressure, the atmospheric pressure is decreasing. And so it's tracking as it rises higher and higher, the wind speeds and basically calculating those wind speeds as it continues to rise. And so we do see a stark difference in wind direction and wind speed. Oftentimes, this is a concern for aviation, especially if those directions and speeds change rapidly in the lower levels. That's when we have wind shear. And so that's definitely something we want to know about.
Okay, yeah, that's very interesting. We had a couple of questions about glacier silt. Michelle was wondering, what is glacier silt? I think you had said that it was dust and dirt that's on top of the glaciers, that you're saying that when the winds are blowing, it can blow them off the glacier. Is that right?
Yes, so glacial silt is the residual rock and dust that's really finely ground up, and it's typically located in glacier valleys. So generally underneath the glacier or from the rocks that the glacier has carried that have been really ground up and finely crushed. And so anytime that we have in the particular location of the Copper River Delta, we have northerly winds, that silt is very easily transported. It can be lifted up and blown through those valleys.
And so does that also affect airplanes, and do they need to be informed of that as well?
That's a fantastic question that I actually don't know the answer to. I'm not sure. Typically, when we see the glacial silt being transported, it's usually lower down. But of course, airplanes land and take off and near the surface. And so that's actually a question I'm going to consult our aviation weather unit here about. I don't know the answer to that.
But it just goes to show that we can even stump our meteorologist. And so a related question about the aviation unit is, Theodore was wondering if the aviation unit uses helicopters and whether the helicopters are hurt by ash, because you're saying that the ash could get into the plane engines. I would assume that they'd also affect helicopters.
Yes, that's my understanding too. Planes and helicopters, really any type of aircraft that is a threat. Volcanic ash is a threat for any type of aircraft, and they would want to avoid any route that contained volcanic ash.
Okay. Well, I know that you have some more information to go through, so maybe we'll move on to your next section and we'll hold the rest of our questions for now.
Sounds great. Thank you. And thank you everyone for the great questions. All right, so we'll continue on here. So now that we have gathered all of the data, it's time to build the forecast and figure out what's going to happen in the future. So we're taking all of the information that we've been looking at. We are thinking about the radar imagery, we're thinking about what we saw in our satellite imagery, and we're using our surface observations to confirm what's going on now, in addition to our data that we collected from the weather balloon. And now we have to put the puzzle together and determine what's going to happen in the future. So if you think about the atmosphere, it's kind of like an ocean surrounding Earth's surface. There are atmospheric waves, just like there are waves in the ocean, and things act and behave very fluidly, like fluid dynamics. So we rely on the help of computers to help us process all of this information. And so the image on the right-hand side is actually our weather forecast office in Juneau. You can see just how many computer screens there are, lots of monitors set up to help understand and process and analyze all of these observations and all of this information. We're also relying on supercomputers to help us with the mathematical processes that go into forecasting. And so that includes the computer helping us to crunch the numbers and figure out what the models are going to do and what the models are hinting at in terms of where the weather what the weather will be like in the future. So we have supercomputers that are processing and calculating all of this information, and they produce, for us as meteorologists and forecasters, we're interested in seeing the graphical output. We studied all of these equations and stuff in school, but it's really helpful to have a graphical image to then interpret what's going to happen and how to craft the forecast for the future. So the importance of observations. If we put good information and good quality data into the supercomputer that then runs an atmospheric model, if that is all good information, we will get good information out. So that's why it's really important to have quality control and ensure that the data we're putting in to the computer and that's being run in the computer model is the best that it can possibly be, because then that will give us a good result, the best possible result that we can get. And so a good analogy that I'd like to use here is, for example, if you were using your smartphone apps, and say you had a couple of different apps that you use for navigation, and you put in that you'd like directions from point A to point B. Maybe the first app that you're using takes into account the current traffic, and maybe the second app that you're using doesn't. So you are effectively getting two different answers. Your time of arrival is different versus when you're using the first app or the second app. And so it's very similar here. We are getting several different answers based on different weather models. So in this particular image, you can see that there are 4 different answers to where this area of low pressure is located, just off the coast of the Alaska Panhandle there in the Eastern Gulf. And in addition to the location being different, the strength of each of those low pressures is different. So it's up to the meteorologist to determine which answer is right. So very similar to the traffic apps on your phone, you'll get a different answer if you have an app that is accounting for and using that information about the traffic versus the one that is not. So that's a little bit more about what we do and how we try to narrow down what the right prediction will be. So in terms of forecasting, once we have an idea and once we think we are leaning toward a particular model solution, we're able to tailor the forecast using what we call our gridded forecast program in our weather display that we use. And so in Southcentral Alaska in particular, and all of Alaska really, there are a lot of challenges with terrain. So we're able to go in and increase those winds where they need to be increased, decrease the temperature where we know that there are colder prone areas like lower level valleys. And so this is part of the forecaster's job too, is to know the terrain and understand the different weather effects that the topography can have. We're also taking that graphical data and translating that into a text forecast. And typically that is what you would see on our website. So as I mentioned, there are some challenges in Alaska. In particular, in the Anchorage area here, we often see gusty southeasterly winds. And while some of these southeasterly winds over Prince William Sound may be about 30 to 50 miles per hour, by the time they travel through Turnagain Arm, that air is being squeezed through a really narrow gap, and it's accelerating. And so by the time it reaches the Anchorage area, sometimes those gusts can be significantly higher, up to 70 to 90 miles per hour. So this is one of the typical effects that we see anytime that we have gusty southeasterly winds. We also do have limited observations. While we have several sites with automated weather stations across the state, there are a lot of locations in Alaska that don't have those sites, that don't have those observations. And so if you think about the weather models collecting all of these observations, if it's missing information for one particular area, it's not going to produce the best possible result. So the challenge of limited observations is also something the forecasters have to think about. And in addition to that, we also don't have nearly as much radar coverage. Up here in Alaska, we have 7 radars, but you can see the comparison, how much of the state is covered versus how much of the lower 48 is covered by radar data. So that's another challenge that forecasters in Alaska have to recognize and realize, that when you're looking at your radar data, not every area is going to be covered. You're not going to know what's happening there. And that's in particular one of the reasons why we do rely so heavily on satellite imagery. And so after we've put our forecast together, we have to communicate it. So that's the last part about forecasting. You've looked at the data, you've figured out what you think the answer is going to be, and then you want to share that information with everybody so that everybody can plan and know what to do or how to dress for the next few days. And so one question that we often get is, what does 70% chance of precipitation really mean? And just to clarify, it does not mean that it's going to precipitate 70% of the time, and it does not mean that it's going to precipitate across 70% of the area, but instead, it's an expression of confidence. It's a way for the forecaster to tell you and communicate how confident they are about how much measurable precipitation will fall. So when we talk about the probability of precipitation, it's the likelihood of a measurable amount of rain or snow. In this particular case, 1/100th of an inch is measurable. And so when we are forecasting, we're breaking down the forecast area into roughly 2 mile by 2 mile square grids, what we call the grids. And so when we express probability of precipitation, we're talking about the chance and the confidence that I have that rain will develop across a portion of that area. So for example, I am feeling 70% certain that rain will develop across 100% of this green gridded square area. And that means that there will be a 70% chance of rain over that area for a certain time period. Now, when we talk about time periods, that depends on which forecast you're working on. So that could be in the next 3 hours, that could be in the next 6 hours, or that could be in the next 12 hours. So it's just important to recognize that we're talking about the confidence level across a specific area and across a certain time period. That's something we often get asked, what 70% chance of precipitation really means. Another way that we communicate our forecasts is through products. The weather forecast offices here will issue blizzard warnings, winter storm advisories, and watches. And so these products are important for notifying people about what to expect. And so there are some differences between a warning, an advisory, and a watch. A warning is high confidence. We see something is going to happen. We are expecting a significant snowfall event or a significant rainfall event. And so we are going to issue a warning to alert the public about that. If we're expecting advisory level criteria, which is slightly less criteria, so maybe not 12 inches of snow, but maybe we're seeing 3 to 5 inches of snow, that's something that we may issue an advisory for to still provide a heads up, but it's not as severe as a warning. And lastly, we may issue a watch. We're a few days out from the event arriving. We're seeing like maybe something will happen. Maybe this storm will track into Southcentral Alaska, or it's coming through across the Bering Sea and moving into the southwest coast of Alaska. We see this maybe 3 days out, 2 or 3 days out. We'll put up a watch to get your attention and say, hey, we're looking at this. We think it may turn into something more, but for right now, we're just watching it, and we'll update you when we have more information. And so, of course, the best way to get your local forecast is through our website. You can start here at weather.gov/Anchorage. And if you click on that map for which area you're located in, or the area that you'd like to get the forecast for, that will be an interactive map that you can then select your specific grid point area, similar to what I was showing before. So here's an example of the grid point area highlighted over the Valdez location. And so that is a specific forecast for Valdez, Alaska. All right, I'm happy to take any questions about that if anybody has anything that they're wondering about.
I think maybe what we might do is hold on to our questions because we only have about 8 minutes left, and I know that you had wanted to talk about careers a little bit, and then we'll take any questions at the end of that, if that's okay.
Okay, great. That sounds great, Lisa. Thank you. So if all of this information has been interesting to you, and you might be wondering, is meteorology for you? Well, these are the 3 main areas that I think are good backgrounds to have if you're considering becoming a meteorologist. There's a lot of math, there's a lot of science, and there's a lot of communication. So if you're interested in one of these or all 3 of these, you may want to pursue or consider pursuing meteorology. Here are some of the things that you might learn along the way, some of the classes that you can focus on. So of course, lots of math, lots of science, including physics and chemistry, oceanography. We talked about how the atmosphere behaves very much like a fluid. So having an understanding of fluid dynamics and thermodynamics is important. Geography, you want to be able to communicate with people about the area that they live in. So understanding where the lakes are located, what those mountains are named, what volcanoes are across your area, and being sure to know and become more familiar with the area that you're working in and forecasting in. Knowing and speaking multiple languages, that will only enhance your ability to communicate weather information. So that's really important as well. Any type of computer skills, whether that be computer programming, maybe you're interested in graphics and web design. Again, that goes along with the communication piece. You want to be able to process all of the scientific information, but if you can't effectively communicate it to your audience, then that's going to be causing a problem, because then people won't understand the information that you're trying to share. And of course, public speaking and also social science. This is kind of a newer area that has become more kind of interdisciplinary with the sciences, understanding as well human behavior and social science to know whether or not people will take action when you issue a blizzard warning or when you issue a flood watch. Are they behaving differently? Are they preparing? Are they doing something different, going about their day differently because of the information that you have provided? So that's a new kind of up and coming area that we're also focusing on. And I can share a personal story with you. The math is hard. I spent long hours focused on solving all kinds of different math problems. And in fact, I did not succeed at first. I had to take a couple of math classes twice during my college career. And I was really upset about that because I was not scheduled to graduate on time. I had to wait another semester to enroll in that math class. And so I was really bummed about not being on track. But it all worked out in the end. I ended up meeting some other people in the new class that I was with. And I persisted through it, and I asked for help when I needed it. And so if at first you think that you're not going to succeed, I would tell you, please don't give up. It is hard, but you can certainly make it through, and seek out support from your teachers, from your friends, from your professors, and from mentors. Absolutely don't give up, because if I had given up when I didn't do well in that math class, I would not be where I am today. So a little bit of motivation for you. There are a lot of different areas that you can take your meteorology career. You can work in the private sector. You can work in public service, like the National Weather Service. Maybe you want to forecast for military operations. That's an area that you might end up in as well. Also, the education sector, maybe you are interested in broadcasting and you're really good at communicating and you want to share that information, whether it be on radio or television. And lastly, research. We need researchers to continue solving all of the problems and figuring out ways to improve the forecast. So maybe those are some of the areas that you would find yourself becoming interested in along the way. And also, lastly, just some ideas to share with you. What can you do as a meteorologist? You may be predicting hurricanes and tornadoes. You might be interested in computer programming and you want to design and improve the atmospheric computer models. Maybe you want to communicate with emergency managers and work on disaster prevention plans. If you're more interested in the long-term trends, maybe climatology is for you. So there really are just a wealth of different options that you can pursue in meteorology if you're considering that as a career. And lastly, part of our job here at the Weather Service, we're working to save lives and property. And so I think that is perhaps one of the most rewarding parts about my job here, is that I'm working to build the forecast and issue watches, warnings, and advisories that then help people plan for the future and know what to do in terms of encountering adverse weather. So that is all I have, and I'd be more than happy to take any questions.
Thank you so much. I think that it's really interesting to see all of the different things you could do as a meteorologist, and it touches on a lot of the webinars that we've had already this year in NOAA Live Alaska. And I know that also if you go and check the NOAA Live webinars out of Woods Hole, they have a lot of different weather forecast related webinars as well. And so we had a couple of weather balloon questions. I know that we only have a few minutes. So one of the questions that Gabe had was, will airplanes run into the weather balloons if they're going up way high?
Excellent question, Gabe. It is possible. And so before we launched the weather balloon, we actually, here in Anchorage, we're located very close to the Anchorage airport. And so we coordinate that before we release the balloon. So we always call to make sure that there are no planes taking off and that there are no planes landing. And then they give us the go-ahead, the okay to launch that balloon. So yes, that is a concern, and we call and coordinate that to avoid that.
Thank you. And my mistake, that was from Haley, not Gabe. Gabe's question was, how many weather stations do you have in Alaska? And I think that you had shown the forecast offices, but does that include all of those remote weather stations that you showed all of the instruments for in that one slide?
So in terms of the surface observations, that does not include all of them. We have a lot of surface observations across the state. For weather balloons, we do have some remote locations for those. We have an AutoLauncher on St. Paul Island out in the middle of the Bering. We also have an AutoLauncher in Bethel. So lots of various locations across the state.
Great. And then lastly, Theodore has been very persistent in asking about whether there are helicopters in the aviation fleet. And so I had wanted to ask you that before we go.
Yes, excellent question. In terms of the Alaska Aviation Weather Unit, I don't know of any helicopters in the fleet, but of course there are helicopters and pilots who are flying in helicopters around Alaska. And so I imagine they pay special attention to the aviation weather forecasts.
Great. Thank you so much, Kaitlyn. And I just wanted to ask if there's one last piece of, I know that you were telling our viewers to be persistent with their studies and not get discouraged, but is there any particular other piece of advice that you would like to give before, as we close up our webinar here?
Sure. I think my piece of advice to share, and I would encourage all of you, is to never stop asking questions. I feel like that's how I learned a lot of things along the way, was because I was always wondering more about the topic, or more about why did this front move so fast, and the models didn't capture that movement moving, in over South Central, or why are the winds picking up sooner than when I thought they would. And so always questioning what's going on and what's happening around you, and seeking answers to those questions has kept me interested and kept me always learning more.
Thank you, Kaitlyn, and thank you for being so inspiring for all of us. I think that you gave us a lot of background in what it takes to go to make a weather forecast, as well as a lot of the different things to keep in mind if you want to go into meteorology. So thank you very much for that.
Thank you, Lisa, and thank you for having me. I've enjoyed sharing a little bit about me and my background with everyone.
Great. Well, thank you to all our viewers. We are actually coming up to our last week of webinars. We have one webinar tomorrow that is on the NOAA Corps that you might be interested in, looking at all of the different types of careers that a NOAA Corps officer can pursue. And then next week is our last two webinars. Tuesday we'll be looking at a NOAA Corps officer's work in Alaska, and with Commander Sarah Duncan. And then Wednesday we have a webinar on the southern resident killer whales. So please join us next week. And also, if you're interested in one of those NOAA Live Alaska patches, please check out our website and fill out the form, and we'll send you one. So thank you very much, and we will see you next week. Thanks.